we've been searching for the next generation of Formula One talent. Look no further than the mechanical engineers at Bath University.
A platform for innovation and the opportunity to inspire.
Helping others achieve their potential through practical learning.
Designing what is verging on the impossible and working hard with the rest of the team to achieve it.
Being part of the ever-growing Formula student community.
An opportunity to develop your engineering, business and communicational skills.
It's building a race car with your mates. What's not to love? Excelling and pioneering in composites design and manufacture.
One of the best ways to build interpersonal skills that are highly valued in industry.
It drives your self-improvement by working with the team to make something that you're really proud of. Hello and welcome to the launch of Team Bath Racing's 2017 Formula Student Car. My name is James Wilson and I'm Project Manager for TBR17. Today marks the culmination of 16 months hard work from the 19 guys and girls sat in the front row who make up the core team, but they've been assisted by 34 other students from different year groups. These guys are some of the most dedicated and hard-working people that I've ever met. And all of us are so excited to unveil that car to you today. But before I do that, I'll give a brief overview of Formula Student as a competition and an introduction to Team Bath Racing and how we operate. Then, once we've revealed the car, we'll delve a bit deeper into the designs and manufacturing techniques that we've used in building it, hearing from the sub-team managers about the key design features and the performance benefits that these will bring. And then we'll finish by inviting you all down to the front for a closer look at the car and a chance to meet the team. So Formula Student is a competition that challenges university students to design and build a single-seat racing car. Since it began in America in the 1980s, it's grown massively to a competition where there's now 663 teams who compete in 16 competitions across 5 continents. Not only does it challenge students to build a car and test that car, but it also tests the engineering understanding and business acumen of these students. These are tested through 8 different events, 3 of which are static and 5 are dynamic. The static events test the design of the car, so we have to justify every single design decision that we've made. And then the cost is a breakdown of every component on the car. So the material costs and also the processes that we use to make them. And then there's a 10-minute Dragon's Den style pitch of a business plan, which revolves around the car. The dynamic events are where the car is performed, and that's where the car is tested. And we start off with an acceleration run, which is a 75-meter straight line from a standing start. The skid pad tests the lateral acceleration capability of the car, and then there's the sprint event, which is a time trial on a highly dynamic circuit. The main event, the endurance, So this is where the most points in the competition lie, and it involves 22 laps of a course with a driver change at the halfway point. It tests driver's focus, but also the reliability of the car, its fuel economy, and the reliability. Formula Student UK is unique amongst Formula Student and also motorsport events around the world. And that is one of the only competitions where a combustion car like ours competes directly against electric cars. To give a better taste of the competition than I could, I'd like to show a short video with the highlights from Formula Student UK 2016, and hopefully by the end of it, you'll be as excited by the competition as we are. Here at Bath, we like to run the project the hard way, but we also think it's the right way. Whereas some teams iterate their designs year on year, maybe tweaking one or two subsystems, we start from scratch every year with a blank sheet of paper. Not only does this mean that the team learns as much as possible about automotive design, but it also gives us a bit more freedom to innovate with new technologies. The 18-month cycle from concept to competition begins in the second semester of the third year, where a group of 20 to 30 students from the mechanical, automotive, and IME engineering disciplines come together as part of the design and business project. From initial concepts, we then bring all those ideas together and come up with a complete design for a single car that we take to Class 2 competition 5 months later. After Class 2, we take on board all the feedback from the judges, and we develop that design over the summer before returning to university in September for our final years. Now, at this point, Formula Student and Team Bath Racing becomes entirely extracurricular. So alongside attending lectures, doing coursework, the team refines the designs and we start building the car. But alongside that, we also have to look after the team's finances, the marketing, sponsor liaison, and also events organisation, and everything else that's involved in running Team Bath Racing as a business. Also, the final year students, we have to start research for our final year projects or dissertations. So whilst these could be on any area of engineering that the team would want to, we tend to look at a particular area of the car that interests us individually. This research then helps either the current car or benefits future TBR years as we look at some really innovative new technologies. Moving on to a bit of Team Bath Racing history. So this approach we have has served us really, really well in the past. Last year's car, TBR17, gave us our best results to date. We started out going to Formula Student UK, where we finished 4th. Unfortunately, that 4th place, we missed out on the podium by just 1.2 points out of 1,000. After that, we then went to the inaugural Formula Student East event at Hungary, finishing 5th, before travelling to the Czech Republic, where we won the competition outright. In doing so, we became the first UK team to win a competition anywhere in the world. These results, combined with the success of TBR15, mean we're currently ranked 6th in the world out of the combustion teams, of which there are 553. To put that success into even more perspective, we're the only British team inside the top 60. The engineering and teamwork skills learned during this project, along with the work ethic required to be this successful, are something that industry really appreciate, and it helps the employability of our graduates. I'd now like to show a short video where some of our alumni talk about how their TBR experience helped them at the start of their careers.
I'm Franco Boates. I was business manager for TBR14. I got involved with TBR in my first week of uni. During the induction week, we had a tour around campus. They took us to the build room. It was the first time I'd ever heard about Formula Student. And then on my first day of classes, I met the project manager because we just happened to sit next to each other in class. So right now I'm studying for my PhD here at Bath, and I've been able to stay involved with Team Bath Racing as a promotion and marketing and 3D rendering expert. I've been the render artist for TBR since 2014, producing design visualizations for launch and business presentations. TBR draws a certain caliber of students that relies on their passion to drive their performance. Definitely the most important thing that I've learned is you get out what you put in. There's always something new to learn, and TBR provides an environment that, as long as you're willing to put in the effort, you're going to reap great rewards.
My name is Leonard Drogala. I'm known as Lenny or Len. I was in TBR16. For me, the main thing was, I'm a practical person, so for me it was a lot of hands-on. The way I joined TBR was through TBR15. There was a session advertised for composite layup, and I was like, sure, I'll come. It was a Wednesday afternoon. I got a couple of hours free, and we were making wheels from TBR14's molds. Describe TBR, seriously time-consuming. But that's down to the individual. I mean, for me, it was time-consuming. I found I found a lot of joy in just getting things done in that environment, and just having a design, pursuing it, accomplishing it, and having it perform, like I said, in the competitions, and just maintaining that faith for the whole exercise. I think is quite it's quite strenuous. Like, it's pretty stressful, but when it comes to competition, you think, yeah, this is cool. My favorite moment has got to be winning a competition. I mean, I personally didn't know it after we won, but that was the first competition to be won by a British Formula Student team. Anywhere, or yeah, in Europe, anywhere. And then subsequently, you actually have to wait months for the world rankings to come out. So we waited, I forget when they came out, but we were 6th in the world out of like 600 or so universities. If you put in a lot of time in something, it bears weight on you. Doesn't matter what it is, I think. And TBR is definitely, is that for sure. And winning a competition just lets you know that what you did was good, was very good, yeah.
Well, I think I certainly agree with Lenny about the stress. Not only does Team Bath Racing help our own graduates, but we also work hard to try and make sure that this opportunity is seen by as many people as possible. By organising workshops and events up and down the country, we aim to inspire and encourage school children to study STEM subjects and consider a career in science, technology, engineering, and mathematics. Also, by trying to get as many University of Bath students involved in the project as possible, not only do we benefit from their support, but by manufacturing and design tasks, help feed their passion for engineering, but also teaches them skills that they wouldn't gain on the academic course. On the screen behind me now, are some photos from some of the sponsor events here on campus that we support. These events give you, our sponsors, direct access to some of the university students, but also events in town and public events display your brand to the wider community. Facebook posts showing just some of the products that you've kindly given us have been seen by our 6,500 Facebook followers. We honestly couldn't have made the car we want to or attend the European competitions that boost our world ranking position if we didn't have the support that we do. So I really can't, and the team can't thank you anywhere near enough for the support that you give us. Now, as I mentioned earlier, TBR17 kicked off the university's 50th anniversary celebrations so well with the win in the Czech Republic and moving us into the top 10 in the world. We now aim to finish those celebrations by winning Formula Student UK 2017. Not only is this because it's our home event, but it's also something that no British team has ever done before. So how are we going to achieve this goal? Well, way back in February last year, when we started out on this project, we set ourselves the design philosophy to maximize transient performance. This means that every design decision that we make is there to improve the car's acceleration, braking, and cornering capability. So with that in mind, it's the time that you've all been waiting for. It's the time where we can show you what our hard work has built. It's time to introduce you to TBR17. I'm so glad that you like it. It's a relief. We are so proud of this car that we've built, but we're equally proud of all the hard work that's gone into designing it and building it. I'd now like to introduce the 4 technical managers from chassis, aerodynamics, vehicle dynamics, and powertrain. We're going to talk a little bit more about the design and the key features of this car and what make it so special.
Good afternoon, everyone. I'm Ollie, the chassis. Look at my card for that. I'm the chassis manager for TBR17. And this year we decided to make our lives a lot harder for ourselves by moving away from the hybrid type chassis that we've seen in previous years to a full carbon monocoque. The reasons are really complicated and I won't go into too much detail, but the headline figures that it's 10% lighter than last year's car on an already really light car and 30% stiffer. So that means during cornering events, it'll be a lot quicker and the driver will also have a more predictive feel of the car. As well as that, there's been some really significant changes in the driving environment this year. So we've changed the seat position, we've changed the steering wheel position, and the cockpit geometry has changed. So the driver's not only comfortable in the car, it's also competitive. As well as this, as you can see on the screen, in my recent render, is that there's shift lights which have been analysed by Guy in the team to ensure that the shifting patterns during acceleration events and also all events are optimal, as we found some drivers were short shifting and we can't afford to lose performance like that. But the main thing that we've been doing this year in the chassis group this year is really furthering our understanding of composite materials. So some of us have worked on the car previously, but this year we've really developed our understanding both of the analysis and manufacture using these sort of space-age materials. The specific strength and stiffness of carbon fibre is exemplary, and we've used that to really reduce the weight of the whole car package, both in chassis and aero. In the analysis phase of design, we've used highly complex FEA software, as well as inbuilt simulation software to predict panel stiffness that's required to do competition. So we spent a lot of time working with carbon fibre, and delivery reflects that. The manufacturing techniques we've developed for the tooling have also improved efficiency of manufacture. So the project was a big undertaking, and we've managed to achieve the target of having a really good looking car which performs well by ensuring we reduce manufacturing times by around 80% this year. Yeah, I'll now pass over to Rob to talk about the aerodynamics, which I don't understand.
Right, so as you can see, the aerodynamics this year have gone quite a big change from previous years. Everything's quite a lot bigger. So we've got a full aerodynamic package, so that's got front wing, rear wing, a really large one-piece floor and diffuser, as well as side wings and barge board. Now, the design philosophy in the aero group this year was kind of to achieve maximum efficiency. Our CFD numbers show that we've got a lift-drag ratio of about 3.4, which is really competitive. And not only that, but we've doubled the downforce numbers produced by last year's car, so that's a big bonus. One of the key points for aero this year is the rear wing mounting system. So we've moved away from the traditional rod and clevis design, and we now have some pretty funky pylons you'll see as you get a close look at the car later, and a structural beam wing. Now, the main advantages of these that it's allowed us to take out a lot of weight in the main 3 elements of the wing, so that's reduced the weight of the whole wing and also shifted the centre of gravity much lower down. Now, we've worked closely with the vehicle dynamics and the powertrain team in designing these pylons, and we've managed to integrate the rear engine roll bar through the pylons and made access to the engine bay for powertrain a lot easier, just as the whole rear wing assembly can be removed with just 4 bolts.
My name's George. I'm in charge of the vehicle dynamics team. So we're sort of responsible for the steering, suspension and brakes of TBR17. A big change this year is moved to 10-inch Avon A92 tyres, which we found were a significant performance improvement over the Hoosier LC0s previously used through on-track testing. Their sort of stiffer, smaller sidewall was found to improve transient performance and also give a more consistent driver feel. These have been mounted to bespoke carbon fibre wheels, so that's again significantly reducing unsprung mass and rotational inertia. We used a U-channel spoke design, which gives a high bending stiffness, but also allows really ease of manufacture. Moving further inboard, we've used double wishbone suspension to actuate vertically mounted spring dampers. Now this keeps all the forces in plane throughout the suspension travel. So that's sort of providing the optimal load paths. So we minimise suspension compliance. We also actuated those through bell cranks to allow the full linearisation of the spring rates throughout the suspension travel. So that gives, again, really good, consistent handling balance. To capitalise on hydraulics that the powertrain Pranav will talk to you about in a second, but we've implemented hydraulics in the powertrain. To capitalise on that, we've also developed an innovative brake steering system. So by braking individual rear wheels individually, we found we could improve turning response, cornering capability, and corner exit traction, which are all key performance enhancements across the dynamic events. I'll now pass you on to Pranav to talk to you about the powertrain.
Hi everyone, my name is Pranav and I'm Powertrain Manager for TBR17. So the powertrain consists of everything in the car that produces power and transmits it to the wheels. So this year we are continuing with our use of a turbocharged single-cylinder KTM 500 engine with a number of modifications to enhance performance and also to achieve our aim of improving drivability and power. So by replacing the stock 6-speed gearbox with a 4-speed one this year, a custom 4-speed one, we have optimized ratios for Formula Student tracks and also saved weight. And also, as Ollie mentioned earlier, with our change to a full monocoque, that's made packaging in the rear of the car a lot harder. So our 3D printed optimized air intake components have optimized airflow and also reduced weight, and they've made packaging a lot easier as well. We've also implemented a solenoid boost controller for our turbocharger system. So this prevents premature pressure leakage through the wastegate, thus increasing low-end torque and improving drivability. And finally, our in-house bespoke hydraulic system for gear shifting and clutch control has really made a big difference to the performance of our car. So what that does is it's a system that operates at pressures of up to 130 bar. And this system has been designed with safety and versatility in mind, which allows for peripherals to be added in easily. And this system allows for really quick and reliable gear shifts and precise clutch control, which is hugely beneficial across all dynamic events. So yeah, that's it. Pass you back over to Joe.
Thank you. Following today's launch, we have 3 more major events this season, the competitions. So we start out at Silverstone in the middle of July for Formula Student UK, before heading back to Autodrom Most in the north of the Czech Republic to try and defend our title in the first week of August. A week later, we return to Hockenheim for Formula Student Germany for the first time since 2014. We'd love it if any of you could come to any of the events, but if that's not possible, please follow our results on our Facebook and Twitter pages. So all that remains before I invite you to the front to take a quick look at the car is for me to thank all the people that have made this possible. Firstly, I'd like to thank all our sponsors. We really couldn't have made that car without you, whether your support has been financial or through supplying us with products or technical advice. It's a massive help to us, and we are really grateful for all of you. Also, every single person who donated to our crowdfunding campaign, we were overwhelmed by the support that we got. The department's technicians, so in the machine shop, headed up by Guy Brace, who machine all our complex metallic components, and from the student model shop, headed up by Andy Church, who taught us how to use the mills, the lathes, who kept it open 10 minutes longer than they should, just so we can finish off the last part. Similarly, Steve Thomas in the composites lab, again for his advice, but also for staying late, as we literally run down the corridor with a part to go into the autoclave for an overnight cure. I'd like to thank the finance office, the department office, and all the academic staff who have ever given a smidgen of advice to any one of the team members. But special thanks goes to Kevin Robinson and Speed Owen. They're the 2 lecturers that run this project, and they've had a huge part to play in the team's ongoing success. Julian Sully, who facilitated the build of our new mezzanine in the build room, which has given us a lot more space, and we filled it within about 2 days. And to Kai Pierce-Rees, who sorted out all our IT issues really, really speedily. And the man who turned off his phone. I'd also like to thank the guys from TBR17. They'll be competing at Class 2 this summer, and alongside the design of their own car, they've built some of our bits, and they've designed some of the components, so thanks a lot to you guys. I'd like to thank Mark Ascott, who brought this team together and led us through our Class 2 competition, and also to TBR alumni, Franco Boat and Kevin Johnson, who put together all the videos and the renders from this launch. So can we please have a massive round of applause for all those people. And finally, I'd like to thank the 19 people who I've spent far, far too much time with. We've laughed together, we've cried a lot together, we've spent many late nights together, but most of all, we built a racing car together. So I'd like to introduce TBR17 to the stage so we can get a quick team photo. And yeah, so you all know who you want to talk to. So if we start out with the Dynamics team, I believe they're led by George, who you met earlier. And then we have Chris Bristow, Mark Ascott, and Tom Simpson. Come on, come on. Go outside, by the car. And then next team is Powertrain, I believe. Yes, got that one right. Who are led by Pranav. And then we have Sam Bunday, who's our business manager, who's organised this launch and has put in a huge amount of work into it. And James Hudson, our testing manager. We have Marius Mazuras, Guy Huxley, Jack Lisniewski, Alex Mercer, and Boon Sheng Lang. The next team is the chassis group, so they're led by Ollie Cartledge. We have Ed Fishwick, Laura Grubb, and Marco Mann. Go in front. Just go in front. And then lastly, my team, the Aero guys, so led by Rob. And then we've got Jack Lindley and Tom Clark, who's also our build manager. So please all come down to the front, talk to any of these guys, anyone in a Team Bath Racing Polo, have a look around the car. And we've also got a really, really cool piece of technology that we're using to show off our design in a really innovative new way. So ask us about that, but it's holograms and mixed reality. It's really cool. So that concludes it. Please come down and we'd love to talk to you.